Okay, back for part two of this one. The first one proved to be, as is often the case with programming, like you have just silly errors. Like I had it all figured out, knock on wood, and then I just fed it the wrong input, and Python didn't like that. So double check your input. That's the lesson learned from the previous one. Okay, let's read through this and see how much we have to adapt our current code to make this work. To completely determine whether you have enough adapters, you'll need to figure out how many different ways they can be arranged. Every arrangement needs to connect to the charging outlet to your device. The previous rules when the adapters can connect are still apply. Okay, so for the first example, the one that starts with 16, 10, 15 supports the following arrangement. So we need to go from 0 to 2 plus or 3 plus the max there, and what combinations can we use? Okay, the charging outlet in your device's built-in adapters are shown in parentheses. Given the adapters from the first example, the total number of arrangements is 8. The second example here has many arrangements. Here are a few. Okay. In total, this set of adapters has 19,208 arrangements. You glance back down at your bag and remember why you brought so many adapters. There must be more than a trillion valid ways to arrange them. Surely there must be an efficient way to count the arrangements. What is the total number of distinct ways that you can arrange the adapters to connect to the charging outlet? Oh, this might be like a programming, like a problem that you need to like do some fancy caching, or else you're going to have problems calculating that. So we've got all the values in here. So what I'm thinking of. Okay, so we can do 1, 2, or 3. Okay, so in this case, we don't need, our logic's a little bit different. We can basically go through every step in there, and so like from 19 to 22 there's one step, and then we can go, -1, -2, -3, and get all those combinations there and check each of those if they have one. And then for each of those, we can check those. So what do we do here? So we can order our numbers, and then we can see which ones are less than 3 from each other. So for example, we've got, what do we have here? So we've got 4 to 5. And then from 4, we've also got 6, and we've got 7. So we've got 1, 2, 3 for each of those. And then from 5, we got 5 to 6, 5 to 7. So we got 2 for each of those. For 6, we've got 6 to 7. For 7, we've got 7 to 10. For 10, we've got 11 and 12. So I think we can just sort of do this mapping where we go through each number in here, and we can count how many expansions or combinations will get us 1, 2, or 3. How many numbers we can get, how many numbers we can reach from that one. Okay, I think that makes sense. So what I want, sort of, I guess, is a dictionary that has the keys in it, and so it's going to have like each number in it, and then it's going to map to which numbers we can get from that. So, so for example, for 1 would be a key and would have 4 as the values in a list from that. For the key 4, we would have 5, 6, and 7. And then what we can do is we can just loop over all of the keys, and we just need to do the product. We can do a reduction on the values in there. I think that will work. So we don't really need to count 0 and 22 in this case because there aren't any expansions from that point. Okay, so I think that's how I'm going to do part 2. Maybe I'll write a test for that. Let's write a test for that. Okay. So here's part 2 simple, or part 1 simple. I'm going to take part 1 simple and call this test simple input part 2. And I'm going to assert that part 2 with our data is going to return, is it 8? 8. Okay, so let's implement part 2, def part 2. It's going to take our input, and I'm going to convert this to lines here. So it'll be similar to this, and I think I don't want it in a list here. Excuse me. I just want it sorted in a list. So I'm going to call the built-in sorted function. I'm going to go grab a drink really fast. Arian says, "What are we trying to get here?" So Arian, we are on part 2 of day 10. We've got really this somewhat convoluted problem set where we've got adapters, and you can go from each adapter, you can go 1, 2, or 3 steps from each adapter position, and we want to get from some number to some other number and count the number of different combinations of adapters we can get there. So I'm going to grab a drink really fast, and then we'll solve this. Okay, so we're going to start at the lowest number here. And so, right, I said I want a result. It's going to be a dictionary. This is going to map line to possible outputs. Okay, and so we're going to say while lines, and I will say line is equal to lines.pop 0. Probably not the most efficient. Popping off the front isn't the most efficient. So maybe I do want to set, just for fast lookup here. Okay, so we're going to start at 0. And so if we start at 0, yeah, so I'm just going to start at 0. I'm going to say cur is equal to 0, and I'll say while lines, and then we're going to say if cur in lines, we're going to say res dot add lines dot res.add cur, and we're going to say lines.remove cur. So we're going to remove that there. And then we're going to say for I in 1, 2, 3. And maybe I'll make this a counter instead. Do I want that a counter? No, I'm just going to leave it as a dictionary for now. Let's see. So I'm going to say if our current value plus I is in our lines, and then we're going to say, we'll just say res.setDefault. Set the default value in this dictionary to a list. So, and that's going to be the default value for cur. And then we're going to say res cur dot append, and we're going to append our cur plus I into it. Okay, so that's going to bump up that number there. And then we'll just bump up current in there. So I'm just going to say cur plus equals 1. And so we're going to, okay, and let's return res here. This is going to be broken, but I just want to see what this looks like here. So I'm going to run this PyTest. I got text is not there. And yeah, input's a bad name. So why is input a bad name? It's a bad name because it's shadowing the built-in input function. Okay, dict has no attribute add. So that's res.add. I don't need that there because I'm doing this down here. So okay, so here is our result. So you can see that there's 1 is followed by 4, 4 is followed by 5, 6, and 7. Let me just pull up the documentation here so we can see both of these next to each other and validate that it's the same. So here's what we want. Here's what we got. So 1 is followed by 4. That looks right. 4 is followed by 5, 6, and 7. That looks right. 6 is followed by 7. That looks right. Maybe I'll just print res here because this is going to fail. It will show the output of that. And so I need to capture that. I'm going to say res is equal to that. And then I'm going to assert res equals 8, which is completely wrong, but I'm just going to print res right here. Okay, so here's our captured output. Okay, so we've got 1 to 4, which is good. We've got 4 to 5, 6, and 7. That looks good. 5 is followed by 6 and 7. Good. 6 is followed by 7. Good. 7 is followed by 10. Good. 10 is followed by 11 and 12. Good. 11 is followed by 12. Okay. 12 is followed by 15. Okay. And 15 is followed by 16. And 16 is followed by 19. So I posit that if we do the product of these values here, we do a reduction with the product of those, that is what we want here. So I think what we want for this let's look for a lambda here. This is going to be, say it's 248, which is not what we want, but we'll just look and see what it says here. And it's not res.values. Yeah, so it's not res.values. Res.values is going to be a sequence of lists, and we don't want a sequence of lists. We want a sequence of the length of the lists. So how do we get a sequence of the length of the lists? So I'll just use a list comprehension to get that. Here's res.values, and I want everything in here is going to be a list, so I'm going to put the length of L, or maybe sec, sequence for sec in this. Okay, let's try this. Okay, assert 12 is 2048. Is 12 what we want here? It is 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, let's look at why we got 12 here. We have 1 times 3, 3 times 2, 6 times 1, times 1, times 2, times 1, times 1. Okay, let me just print out our dictionary here. I'm going to call this the lens is equal to that. And then I'm going to say the lambda of the lens. If you reduce that with the product, it's equal to, should be 12. And we'll print the lens here. Okay. 12. Did I want 12? 8. I don't want 12. I want 8. Okay, let's try it again. Okay, so we've got 1 times 3, which is 3, and then we got 2, which is, that's 6 times 2, which 6 times 2, which is 12. So why aren't we getting 12? Okay, so for 1 there's only one option. For 4 there's 3 options. For 5 there's 2 options. Am I doing the math wrong here? Yeah, I think my data structure is wrong. So every time we have another option here, we're not necessarily doubling that. So for example, for 4, we've got 3 items here, but you can see that the 5s are half of them, and the 6 and 7s are composing the other half there. So there's the 6 and 7s, which are 4 of them, and then there's the 5s, which go to like 6 and 7 as well. So I've got a logic error here. It's not quite right. Okay, so let's think about what we can do to make this work. Okay, so what I'm thinking now is we want to use, back to our famous example here, one way to represent this would be a DAG or a graph. And so we could have 1 mapping to 4, and then 4 mapping to 5, 6, and 7, and then 5 mapping to 6 and 7, and 6 mapping to 7. And so, which I think is what I have down here. 1 mapping to 4, 4 mapping to 5, 6, and 7. Okay, but then instead of multiplying these out, what we want to do is we want to count the number of paths through that. So if we want a path through that, we want the number of traversals, depth traversals through there from one end to the other. 16 to 19. Okay, so yeah, so I think we're going to have to change our plan of attack here. Instead of doing this product with the reduction here, what we'll need to do is we'll need to do a traversal of this. And that should give us the result. So we've got our code from day 7 for doing traversal. I'm just not sure of the enumeration code to enumerate all the traversals. So generally when you're doing a traversal, you'll do like a breadth first search or a depth first search to find something in that. But now we want to count all of those traversals through this graph. So I'm going to think about this for a minute. Trying to solve this without necessarily looking at anything else. I mean, I think I could probably like go to Wikipedia and do like depth first traversals and enumerate all the depth first traversals in there. What would be another way? I think I can just write a little function that enumerates through them. So let's try and do that. I'm going to try and enumerate through them. So part 2 here is returning this res here, which is like our map, and we're going to make another one that's like count traversals. Okay, and maybe like if we did something like this, like we said, count traversals, and we had a map that went from like 1 to 2, then the count of that would be 1. But if we had a map that went from like 1 to 2, and then like 2 to 3 and 4, and then 3 to 4, there should be 2 in that. Okay, so that's what I'm thinking here. And maybe if this went from instead of 1 to that, it went from 3. So this would now be have 4 entries in that. Okay. So let's make a generator that's going to be called traversals, and it's going to take what's it going to take, a graph or a mapping, and a start, and it's going to say so maybe we're going to say like path. What are we going to do? We're going to sort of make a list and then append into the list for every child in that. Yeah, this is the fun part here. We're coming up with these graph algorithms here. So I could, so I'm starting at my start, so I could say like yield start, and then I could say like for child in graph of start. And then for every child in there, I could say yield from traversals from graph and child, where we're starting from. Okay, so that's going to give me my first node here. It would give me like 1, and then we're going to say for children in graph of 1, which would be 2 and 3, we're going to yield from traversals for 2. And so 2 would come in here, we would yield 2, and then we would look at the children from 2, which would be 3 and 4. So 3 would come in here, we would yield 4, and then 4 would come in here and we would yield that. Okay, so let's just try this out. I'll put a little doc test here. Maybe we're going to see if this is going to work, and I'm going to throw it into a list. Materialize this since it's a generator. And let's run PyTest. So I did get this part here, which let me just, we're asserting that this is 8. I'm just going to assert that this is 12 here. We'll just leave that in there. Okay, so that's running. I'm going to say doc test modules to run the doc tests here. And it says traversals is missing the start. So let's add the start here. And the start here is going to be 1. Maybe I'll just, yeah, let's just go for it and see what happens here. Traversals missing 1 required. Start. There we go. It wasn't in the call there. Okay. And so if we get a key error here, if we get a key error, then we're going to, I guess we'll break out of this. So we might get a key error right here. So we could change this to a get start. And if we don't have any of that, we're going to get an empty list. Okay, so I got 1, 2, 3, 4. So 1, 2, 3, and then 4. And then I got a 4 from 2. And then I should have had a 3 and 4 from that. Okay, so So this is actually all three of my, or 1 through 2. Okay, so how do I split this up into, I kind of want it to be like a list of all of the possibilities from that. Maybe I can do something like this. I can maybe put like a token in here. Like after I've done this, I could say like yield end. Let me just throw this in here. I just want to see what's happening when we do this. For child in that, and I don't, so 1, 2, 3, 4, then end. Why did we get an end again? And then a 4, then end and end and end and end. Yield from traversals. Okay, so this is the recursive. I mean, the other day I had problems with recursive, but we did the iterative that I just copied from Wikipedia. Let me try the iterative, which I copied from Wikipedia. I'm going to say traversals, it here, iterative, and we'll do the same thing here. We'll say graph start, and we'll say like, we're going to have like a queue here. So here's our queue, and it's going to have start in it. And then we'll say while queue, and then we're going to say yield queue.pop 0, and then we can say for child in graph.get, we're going to get whatever our node is. I'm going to say node is queue.pop. So we're going to yield our node, and then we're going to get the children of our node, and then we will append those into queue.append node. Okay, and there we can keep a notion of like whether we've seen something before. But we really want like the path through it, right? We want to say like we started at 1 and then we went to 2, then we started at 1 and went to 3. So this would be a breadth first search, which we don't really want. We want a depth first. Okay, I guess I'm gonna call in the big guns here. I'm gonna do a Wikipedia search for depth first. Let's see what we get here. Wikipedia enumerate depth first traversals. Okay. So here is tree traversal. Breadth first surge. Okay, so not seeing. I mean, that's depth first search. We want to get all the traversals here. So, hmm. I get, just gonna. I'm just thinking about this. Yeah, I apologize that this is another one that's sort of throwing me for a loop here. Um, I'm gonna draw out the picture for this right here. So let me get a piece of scratch paper here, and I'll draw it out, and then I'll show it on my camera here. So 1 goes to 4, and then 4 goes to 5, 6, and 7, and then 6 goes to 7, and 5 goes to 7, and then 7 goes to 10, and then there's 11 and 12, so 10 goes to 11 and 12, and 12 goes to 15, and then there's 16, and then 15 goes to 16, and 16 goes to 19. Okay. So I have, let me put my screen up here. I have this little drawing here of my traversals through here. So I've got 1, 2, 3 through that, and then through here I've got 3, and for each of those 3 I've got 1 down this side, and I'm going to have another one down that side, so that should be 6, and then for each of that I'm going to have 1 down here and another one down here, so that I'm counting 12. So something's messed up with what I'm seeing and what they're seeing here. Oh, it's because like 1, 2, 3, 4, 5, 6, 7, 8. Hmm. Okay, well, I don't know that there's much value in you watching me think for a minute, so I'm going to end this here and chew on this a little bit more. I'm going to try not to cheat too much. I don't want to look at anyone else's answers. I mean, it's just a matter of enumerating the possibles through my graph, which I think I have the graph correct. I just need to enumerate those correctly. So I'm going to chew on that, and hopefully I'll come back with an answer.